Hello. All right. Finally, part three of U sub. This is really just going through problems. If you feel like you look at a problem and you totally understand how to do it, then don't worry about attempting it. But I think this is a variety of problems that we could see that may be helpful for us to be able to U sub. So take a minute, pause, look at these. If you know how to do them, move on. I'm going to guess there's at least one in here that you're not 100% sure on. So I'm going to go through and solve them. Okay, for our first one, again, we always look for wherever we're going to be able to substitute out. Our problem here is with the exponent, right? This x squared plus 2x. So I'm going to make u equal to x squared plus 2x. This is an indefinite integral, so I don't have to worry about plugging in the bounds. However, this gets me du dx equals 2x plus 2, which means dx is equal to du over 2x plus 2. We'll be able to cancel out that x plus 1, but we'll have an extra 1/2 on the outside. So now this becomes 1/2 e to the u du, which is super easy to integrate because the antiderivative of e to the u is just e to the u. So this becomes 1/2 e to the u plus c. And our last step is, hey, plug u back in. So 1/2 e to the x squared plus 2x plus c. Technically, the 1/2 applies to the c as well, but we don't really care about that because it's a constant, and if you multiply a constant, it's still a constant. So not something to worry about. For this second one, the only thing we really have to deal with the u sub is this 5x. The x squared and minus 3x are totally fine on their own. We can just do the antiderivative of those as they are. That'll give us x cubed over 3 minus 3 halves x squared. However, dealing with secant squared, the derivative of tangent is secant squared. So this is going to become tangent of 5x. However, we have to undo that chain rule, and this becomes a 1/5. So plus 1/5 tangent 5x, and then a plus c. Technically, what's going on here is we're saying dx is equal to, or sorry, we're saying 5x is equal to sorry, no, we're not even doing that. That's too much work. I was gonna have 5x equal to u and then plug it in, but then you realize you have to divide everything by 5, and that's gross. So let's just say it's really doing one piece. Final one. We're actually, again, notice how this is just an e to the x. We're just gonna divide everything by e to the x. So this becomes the integral of e to the x plus 2 plus 5e to the negative x dx. Again, remember, division means subtract the exponents. So e to the 2x divided by e to the x, that's just e to the 2x minus x, which is just e to the x. Now this is really easy for us to deal with because the antiderivative of e to the x is just e to the x. Antiderivative of 2 is 2x. And then the only thing we have to really worry about here, you could technically use u sub with the negative x. But again, I think it's easier just to think about this as, hey, you're going to bring down that negative, so let's just bring it down. And then plus c. Again, I really don't think you have to use u sub as much of h and I, so much as you need to know, hey, chain rule exists. Let me undo the chain rule. You could use it in either one of them, but I think it's kind of more work than just being okay with that. Same kind of goes with J. J, I wouldn't really use U sub for either, but I definitely would use U sub in K. So take a second, try this out, make sure you're good with these two. Okay, first one, I'm really just saying, hey, what's the antiderivative of cosine of 2x? Well, the antiderivative of that would be the sine of 2x. And I have to say, well, how would you deal with this 2? That would come out due to the chain rule. Let's just make a 1/2 in front. What's the derivative of negative sine of 2x? Well, that would just be cosine of 2x. And again, what do we have to do to undo this chain rule? Let's just throw 1/2 out front. And then the final one, of course, C, it's your boy. It's constant. It's here for you. So be ready. It's always there for you to cry on its shoulder. All right, last one. We're doing U sub on the denominator here. this is going to look like the following. I'm going to let u equal 1 minus 2x squared. This isn't a trig identity that we have because that's a cube root, and cube roots don't really deal with trig identities. Then we have du dx is going to be just negative 4x. So dx is equal to du over negative 4x. I think the other big thing to talk about here is some of you might want to just deal with saying maybe negative 2x squared or 2x squared is only u. However, anytime we can throw in a constant as part of our u is great because the derivative of that is going to be 0 and we don't have to worry about it. So if we had instead said u was, the just negative 2x squared, we still have 1 minus u, and that's not really great. Let's plug this in. This now gives us the integral of, okay, so the dividing by negative 4x and the x just makes it a negative 1/4 outside. And if you want to keep that inside, you keep that inside. And then cube root of u, du. If you really want to rewrite this, you can as u to the negative 1/3. That may help you in terms of, hey, I'm undoing the power rule, but that's up to you. Negative 1/4 still stays out front. We're undoing the power rule, so we add 1. This becomes u to the 2/3. And then, of course, we have to deal with this new power, so we're going to multiply by its reciprocal. This then simplifies down to, sorry, I got to erase stuff. This simplifies down to negative 3 over 8 u to the 2/3. And then we just got to plug u back in. So negative 3/8 times 1 minus 2x squared to the 2/3. Please do not try to distribute out the 2/3. You could technically cube root it and then have that thing squared, but like we could also not worry about it. Of course, your friend forever, C, your BFF. Okay, let's try a couple more. These next couple, specifically n is tough. N is using a trig identity, but the other ones aren't bad. So pause the video, try the rest out. Okay, for I, we're gonna, again, the big piece here is that this cosine is the thing raised to the power, so it's cosine to the 4th. If this were sine to the 4th, I would use sine as my u value, but because it's cosine to the 4th, we're gonna let u equal the cosine of x. This means when I plug it in, I'll end up with a u to the 4th, which is not bad for me to deal with. Du dx is negative sine of x. And I think you can see how dx is just du over negative sine of x. So we're going to divide out, and we're just going to have an extra negative in here. So this becomes integral, negative, and then u to the 4th du. So what looked like trig is really just me taking the antiderivative with power rule, right? And so this is going to become negative 1/5 u to the 5th plus c. Our final thing, of course, always in an indefinite integral, replace your u. In a definite integral, you don't have to, right? Because you swapped out your bounds. But with a indefinite integral, we got to plug that u back in. It doesn't just go away. You have a final answer with u, you're not getting credit. I mean, maybe partial, but not like credit. So final answer, negative 1/5 cosine to the 5th of x. If you're a person who doesn't like raising your cosines to powers, I don't know why that harmed you, but you could technically put parentheses around the whole thing and make it to the 5th. You cannot do this. This is illegal. That's saying cosine of the quantity x to the 5th. Don't do that. No one likes that. It's wrong. Next one is kind of dealer's choice on which one you want to use sub. I'm going to use sine this time just because it's a cleaner du dx, right? It'll just equal cosine. And then that means that dx is equal to du over cosine of x. So we'll cancel out that cosine really quick. This just gives us the integral of u du, which again, we're undoing a power rule here. This gets us a 1/2 u squared plus c. And of course, we just got to plug u back in. So 1/2 sine squared x plus c. So that's always a fun time. Now, for the last one, is using a bit of an identity. And this isn't one that we've talked about a whole lot, so I don't expect us to have this one memorized. We actually have an identity here that says the sine squared of x is equal to 1 over, let's wait, 1 plus, I think it's plus, the cosine of 2x over 2 and dx. If we want to, we could deal with this as, oh, sorry, it's actually minus. I'd hate to lie to you. It's a minus. This is something we can do pretty easily with u sub at this point, but we could talk about this in a different way, trying to deal with the sine versus cosine, but it's not really a great, you can't u sub here because there's nothing to cancel out. You're not going to cancel out the other sine versus cosine. So we instead use this identity. This then becomes just 1/2 x minus, and then we're going to get a 1/4 sine of 2x plus c. Again, this is highly dependent on you knowing this identity, which I don't think is something you have to have memorized. But I'm just here to show it to you because that's maybe you'll see it someday, and maybe you'll remember. Maybe you won't. I don't know. Got a couple more. These ones are big with the square roots. Square roots are super important, and we're going to talk about how we might be able to solve this using some u sub in general. Yeah, try it out. See if you can tackle it. If you can't, come back. Okay, so our problem here, and we talked about this a little bit the other day, and it was the issue of if you just have like a square root of x, that's super easy for me to like distribute to equality. I can distribute those to equality and not really have any type of issue. However, the moment that we have something with that radical, like a +1, now we're in a little bit of trouble. So we're going to instead call u equal to x plus 1, which means du would just be, or du dx is just equal to 1, or dx is just equal to du. Which you might be saying, well, Mr. Erb, why are we doing this if you're not canceling anything out? And it's really just to move around the bounds. So this becomes square root of u, du, right? This x, however, well, if u equals x plus 1, then x is equal to u minus 1. So now this becomes u minus 1. And from here, we can just distribute, right? We'll actually be able to take this and rewrite it as the integral. Well, u times u to the 1/2 would be u to the 3/2. This is me just distributing the square root of u. And then minus u to the 1/2 du. Because again, square root of u times -1. Now all we have to do is power rule. Well, undoing power rule, right? So this becomes u to the 5/2 times 2/5 minus u to the 3/2 times 2/3 plus c. Our final step is, hey, you got to plug u back in. You can't just leave it out there. So we're going to make that x plus 1 to the 5/2. And then minus 2/3 times x plus 1 to the 3/2 plus c. And there you go. Again, this is more helpful than, you can't really distribute the square root of x plus 1 with the x because it doesn't multiply nicely. So think about that when dealing with it. We're going to use that same strategy for q. We're going to say, hey, I have an issue again. I'm going to let u equal x plus 1. I think you see where this is going. du equals dx. And so this becomes square root of u again. But now, instead of a x, we have an x plus 10. So x is still equal to u minus 1. So this just becomes u plus 9. And then du. We're going to, again, distribute this whole thing. So this becomes u to the 3/2 again, plus 9 u to the 1/2 du. And then integrate that sucker. So this becomes 2/5 u to the 5/2 plus 9 times, well, it's u to the 3/2. And so 2/3 times 9 would be 6, then plus c. And of course, gotta plug it back in. And there you go. Again, always remember, hey, this is an indefinite integral, so we don't have bounds. We gotta plug u back in. Speaking of definite integrals, though, look at S there. Man, S has some stuff. Pause the video here and see how you do. Okay, for R, the first thing I'm going to do is I realize natural log of X is probably the better thing to take as U here, because just using X isn't really going to do a whole lot. However, du dx is equal to 1 over X, which now means that instead of dividing by this X, right, dx is equal to du times X, right? And so now we're going to cancel it out in an interesting way. This just becomes 1 over u du. So when we take the integral of 1 over u, that's a big red flag of, hey, the antiderivative of that is natural log of the absolute value of u. But now we just have to plug the natural log in, so it gets the natural log of the absolute value of the natural log of X, which is super weird. Again, it's a nested natural log, but that's the only way to really kind of get it. Think about this as if you were doing chain rule, this is exactly how this would look like, right? All right, with S, we actually are gonna just do our u sub, right? We're gonna say 1 plus 2x squared is equal to u, so du is equal to 4x. Oh, du over dx is equal to 4x. And that means dx is equal to du over 4x. So we're going to plug all that back in. This now becomes a 1/4 on the outside integral, and then 1 over square root of u du. However, because we have bounds here, we have to plug those back in, which means we don't have to plug u in. Once we integrate, we don't have to worry about plugging u back in. We plug 0 in. If x equals 0, that becomes 1 plus 0 equals u, so the lower bound's 1. And then we do the same thing with 2. That becomes, if x equals 2, that becomes 1 plus 8 equals u, so u is 9. Now, again, we're just going to take the antiderivative of 1 over the square root of u, which would really just be 2 square roots of u. And again, of course, there's 1/4 still out there, and 1 to 9. If you're not sure about that, remember that 1 over the square root of u is equal to u to the negative 1/2. And we're just undoing power rule, right? So we'd add 1 and then multiply by the reciprocal. I'll make that a 1/2. And then all we have to do is plug our values in. So 1/2 times the square root of 9 minus 1/2 times the square root of 1, which not bad because this is just 3/2 minus 1/2, or just 1. So final answer there, in case you weren't sure, is 1. All right, last one. We have this cosine of e to the x, and then we got an e to the x outside. The fact that we have an e to the x outside makes me believe it might be good for us to use e to the x plus 1 as our u here. That means du dx is equal to, you guessed it, e to the x. So dx is equal to du over e to the x, which is super great because then this just becomes the integral of the cosine of u, du. That's equal to sine of u plus c. And our last step is replacing u. Again, this is an indefinite integral, so we got to put u back in. And there you go. There's a whole bunch of problems with u sub. This is not all of the problem types, but it covers a good variety. So hopefully this gave us a lens into it. We didn't cover some of the trig identities, and we're going to look at arc sine, arc cosine, all that fun stuff later on. Not necessarily in here, but those are clutch and something we need to know as well. All right, as always, if you have any questions, reach out. Otherwise, have a great day.